So now let us proceed to our next topic, that is electrode potential. What is electrode potential? It is the potential difference that is developed between the metal electrodes and its ion in the solution. Okay, so the potential difference developed between the metal electrodes and its ion in the solution. So now on which things or the terms will this electrode potential will be depending. So the factors affecting it will be concentration of the solution, because the ions will be present in the solution only, and that will directly differ the potential difference between the metal electrodes and its ion. Okay, then nature of the electrolyte, nature of the metal, and pressure temperature conditions. Okay, so four factors: concentration of the solution, nature of matter, nature of electrolyte, and pressure temperature condition. Now electrode potential can also be classified in two main types, that is oxidation potential and reduction potential. Very simple, pretty obvious from the name only. Oxidation potential will be the electrode potential for the oxidation half reaction. Therefore, the greater the oxidation potential, the greater will be the tendency to get oxidized, right? Whereas in the reduction potential, the electrode potential for the reduction half reaction, that's all. And therefore the greater the reduction potential, greater will be the tendency to get reduced. Simple as that. So electrode potential developed between the potential difference developed between the metal electrode and its ion solution. Four factors affecting it will be nature of electrolyte, nature of metal, concentration of solution, pressure, and temperature conditions. Electrode potential broadly classified in two types: oxidation potential, reduction potential. Oxidation potential, electrode potential of the oxidation half side, while reduction potential, the electrode potential of the reduction half reaction. While greater the oxidation reaction, greater the tendency to get oxidized. Greater the reduction potential, greater will be the tendency to get reduced. So now if we talk about the different types of electrode and their reaction in the standard condition, we would broadly classify the type of electrode in four types, that is metal electrode, hydrogen peroxide electrode, redox electrode, and metal salt, that is insoluble electrode. Right, so metal electrode, both the anode and the cathode will be metal strips, for example zinc electrode or copper electrode, and their reaction can be very easily concurred in reduction and oxidation. For example, in the case of zinc electrode, reduction can be written as zinc 2 positive plus 2 electron gives us zinc solid, right? While in the case of zinc only giving oxidation reaction, zinc solid will be converted into zinc 2 positive plus 2, giving up 2 electrons, right? So this is going to be pretty simple. Coming to the next, hydrogen peroxide electrode. This is a very rare type of electrode we used to see, but mainly we conquer this type of question in competitive exams. So in this, what happens is ki reduction will be taking place when H2O, water, will be formed by the help of H2O2, right? So with the help of 2 electron plus 2 H positive ion plus H2O2, 2 H2O will be formed. That is the reduction reaction in this particular electrode, right? While in the oxidation, H2O2, hydrogen peroxide, will be giving oxygen and 2 electrons and 2 protons specifically. Okay, so again the standard oxidation potential and standard reduction potential can be written very easily in this type of electrode also. Coming to redox electrode, here reduction will take place, like for example MnO4 converting into Mn2 positive via reducing it with the help of 8H positive ion, 5 electrons, and leaving behind 4H2O also. Metal salt insoluble electrode is something where both the ions get to dissociate in the reduction cell, and in the oxidation cell both the ions get associated. For example, AgCl will get one electron and dissociate in Ag solid plus chlorine ion in the case of reduction, and in the case of oxidation, Ag solid plus chlorine ion will give us AgCl solid with one electron. Simple as that. So now we are having our standard electron potential. See, whenever we used to talk about electrode potential, so there will be two conditions. One will be standard condition, one will be non-standard condition. So for calculating standard electrode potential, we are having a list of electrochemical series due to which we can help in getting the standard electrode potential. While in the case of if the standard medium is not present, standard conditions is not present, we used to use Nernst equation. Okay, so what are these standard necessary conditions? These are that the solution of the ions, that the potential difference developed between the metal electrode and the solution of its ion should be at 1 molarity concentration and at 1 bar pressure and at 298 Kelvin. So when we are given by this condition, we used to write it as standard electrode potential or simply reduction potential. While in the case of when these particular three necessary conditions are not present, either the concentration is not 1 molar or the pressure is not 1 bar or the temperature is not 298 Kelvin, we will use Nernst equation. But the common thing between both of these is the electrochemical series. Now, what is electrochemical series? It is a series where metals are arranged in the increasing order of their reduction potential. The increasing order of their reduction potential. The metals placed above can displace the metals placed below them, or the metal ions placed below them. Okay, so low reduction potential metal will have a high negative value and will undergo oxidation, whereas high reduction potential metal will be having a positive value. Okay, so till this you should revise the content of the first video, and we will continue with standard hydrogen potential.